Hey guys, today's topic is circles. Okay, so a circle is the set of all points in a plane equidistant from a center point. Okay, so equidistant, of course, meaning it's the same distance away. So we got some terms here we got to know, like what is the center? Okay, so the center is this point right here. We'll call it C. The center is the point that is exactly in the middle of the circle. Basically the point where the circle is built off of. Okay? All right. Let's talk about radius. Okay, the radius, which is usually called r, like this, is the distance from the center to any point on the circle. Okay, so it goes from the center to any random point along the circle. Okay? A chord. Okay, a chord is a segment connecting any two points on a circle. So this right here is a chord. Notice I'm color coordinating everything so it's all the same color. Now a diameter, let's go back to chord for just a second. We'll call this point right here A, and we'll call this point B, and so the chord would be segment AB. Okay, and up here, the center would be point C. The radius, we can call the radius, we'll call this point D right here. So the radius would be segment CD. All right, so diameter. A diameter is a chord that passes through the center. Okay, so we call this point E, call this point F, and that would be segment EF. Okay, it's a chord just like AB is, because it's got 2 points on the circle, and the segment connects them, but it does pass through the center, whereas AB does not. It is also the longest chord on a circle. Okay? Okay, a tangent. Okay, so a tangent is a line that intersects a circle at exactly 1 point. Okay, so that would be, let's put a point, what haven't we used yet? G. Right here. So this would be line GD. It's a tangent, okay? So it's a It's a line that comes by here. It just kisses the side right here at point D, and then it just keeps going. The point of tangency is the point, in this case it would be point D. It's the point where a tangent line touches the circle. Okay. And lastly, we have a secant. Okay, a secant is a line that, whoops, that passes through a circle. Okay, so this is a secant right here. It comes through and it touches the circle at exactly 2 points. Okay, and let's call this, I don't know, H, and we'll call this J, so that would be line HJ. All right, so there's all your parts of a circle and all the things that go with it. So again, you've got a center, you've got the radius, you've got a chord, you've got a diameter, which is a chord that goes through the center, you've got a tangent that just touches a circle at one point, at the point of tangency, and then you've got a secant that passes through a circle. Okay. So here we have a circle with something called a central angle. Okay, so let's start with that. A central angle is an angle whose vertex is the center of a circle. Okay, so here's the center of the circle. That's also the vertex of the angle. Okay, so this is a central angle right here. In this case, that would be angle ACB. Okay, now what this does, it divides the circle into two parts. It divides it into a minor arc. So a minor arc is an arc that is less than 180 degrees. Okay, so this is an arc. It's a curve along the circle here. That's a minor arc because it's less than 180 degrees, and we write it like this. Arc AB. You could also call that arc BA if you like. A minor arc is always named with two letters, and it's always the ends, okay? So I could have another point right here, call it R, but I would not call that arc ARB. I would only call it arc AB. Okay, then we have a major arc. A major arc is an arc that is greater than 180 degrees. Okay, so in this case, that would be arc AQB. Now, you always name a major arc with three letters, okay? Because if I call this just arc, and that's referring to this part out here. The reason I have to use three letters, if I just call it AB, then I'm looking at this part right here, okay? So the major arc always has a third letter. It doesn't matter which letter. I could have a whole bunch of points along here. If I wanted, I just pick one. Okay, a semicircle is an arc of exactly 180 degrees. Okay, I don't have a semicircle on here, but I could make one real quick. Let's do this. Okay, so that's a diameter. It's going to give me a couple more points on here. Let's call this D, and this point E. Okay, this makes two semicircles now. I've got semicircle DQE, and I've got semicircle DAE. Okay, so these work just like major arcs. You always use three letters, and it doesn't really matter which point is in the middle. On this one, I don't really have a choice. I only have one point Q, but I could have called this DAE. I could have called it DRE. I could have called it DBE. It's the same. Okay. All right, an inscribed angle. An inscribed angle is a little different than a central angle. Okay, so let's do this. Put that point right there. Little circle right here. Kind of missed my center there a bit. Okay, a central angle, or an inscribed angle, sorry, is an angle whose vertex is on the circle. Okay. So if this is A, B, C, notice that the vertex of this angle is on the circle. So an inscribed angle is an angle whose vertex is on the circle. Oops. Can't spell today. And this also must be true. Both sides of the angle pass through the circle. Okay, so that eliminates things like this. You don't want this. This is not an inscribed angle. Okay. This is not an inscribed angle either. Okay, so those two things are not inscribed because both the sides don't pass through the circle. This one has one side that does, this one doesn't. This one, neither of the sides do. Okay, so those are not inscribed angles. We're going to go ahead and get rid of those. Okay, what are concentric circles? Concentric circles would be a series of circles with the same center. Okay. Like that R. All right, so what does that look like? Well, if that's my center point, I could have this circle, this circle, this circle. That would be concentric circles. They basically form a target. Okay? All right, here's our first theorem. The measure of a central angle is equal to its intercepted arc. Okay, so here's my central angle. It has a degree of 65 degrees. Okay, now what that means is if I were to measure this arc right here, it would also be 65 degrees. Now, there's two different, totally distinct ways of measuring an arc. You can measure its angle. That's what we call the measure, or arc measure. And it also has a length. So the arc length would be if I was standing at point A and I walked around the edge of this to point B, how long did I walk? That's a different thing. Okay, right now we're talking arc measure. That's an angle. It's usually in degrees. Sometimes it's in something called radians, which we'll talk about later. Okay, but this arc and this central angle are always equal. And I don't want that to be 6.5, so. Okay. Now I can also figure out, once I know this arc, I can figure out this arc over here because there's 360 degrees in a circle. So this would be 295 degrees over here. And then if I measured this angle, it would also be 295 degrees. Okay, so here's what I want you to do. I want you to take a second. I want you to pause the video. I want you to look at these items on here. How far does this go? Okay, so there's semicircle and major arc at the bottom. It's kind of hard to fit it all on one screen. I want you to identify each one of these items and then check back here. We'll start the video back up and you can see if you got them all right. Okay, so go ahead and pause the video and go ahead and do this. Okay, so the center point, of course, is Q. An inscribed angle. Okay, so there's a couple of inscribed angles here. You could have had this angle right here. That would be angle RVQ. You could have had this angle right here. That would be angle VRQ. Wait, yep, that's right. You could have this angle up here. Would have been angle U or VUQ. And you could have this arc right here, or this angle right here, which would have been UVQ. So any one of those four would work. Okay, find a radius. Well, there's several radii on here. So one of them would be VQ, or we'll call QV. How about QU would be another one. QT would be another one. QS would be another one. And QR, I believe, is the last one. So any one of those five. Okay, a secant. There's only one secant on here, and that is line UV. Of course, I put the little line sign above it. A tangent, there's one tangent on here. That would be line UW. A diameter, there's a couple of diameters. You could have said US, segment US. You could have also said segment VT. A point of tangency. Well, there's only one point of tangency. That would be point U. A central angle. Okay, there's a whole bunch of central angles on here, and I'm not going to write them all down. But these are central angles in here, so I'd call this one VQU. I could have had this angle right here. That'd be angle UQR. Okay, there's about 10 more of them. Well, there's not that many, but there's a bunch. Okay, a minor arc. There's a couple of different minor arcs in here. In fact, there's 5. There's probably more than that. So I'm not going to name all of them, but one of them would be arc RV. VU would be another one. UT would be one. Okay, so there's a bunch. A major arc. Okay, that one's more than 180 degrees. So that would be like arc UVT. Let's see. Oh, SUT would be another one. And a semicircle. Let's see, there's 4 semicircles on here. So I could have UTS would be one. The other side of UTS would be UVS. And I can do the same thing with V and T. So I can have VUT. Whoops, I just about put the wrong symbol on there. And the other one would be VRT. All right, so hopefully you got all of those correct. You didn't have to have all these, just had to have one. All righty then, so you got your assignment attached to the back of this. I look forward to seeing you guys later, and have a great day.